Let's solve homework exercise number 8 from section 11.3 homework exercises. The problem states to win the lotto in one state, one must correctly select 4 numbers from a collection of 49. All right, the order in which a selection made does not matter. So how many different selections are possible? Since order does not matter, it is a combination. Okay, now, so it's a combination, and the total number we're working with is 49, and the number we're going to select is 4, so 49C4. If you follow the formula for combination, you do 49 factorial divided by 49 minus 4 factorial times 4 factorial. Okay, now again, you got your keys on your calculator, which I'll show in a minute. So you could do, so this would be 49 factorial divided by 45 factorial times 4 factorial, which would be 49 times 48 times 47 times 46. And then 45 down to 1 is 45 factorial, right? So that, and we got a 45 factorial in the denominator, so those cancel. And then we still got 4 times 3 times 2 times 1 in the denominator. That's 4 factorial. So that would be your answer figuring it out. So again, if we do that on the calculator, we would have 49 times 48 times 47 times 46. Oops. Yeah, divided by, and then it was 4 factorial, 4 times 3 times 2 times 1. Whoa, did something. All right, let's try that again. I just put in the wrong key probably. 49 times 48 times 47 times 46, and 45 factorial canceled. Oops, 46. Can't put, not pressing the right keys. Okay, divided by the whole quantity needed in parentheses, 4 times 3 times 2 times 1. Hopefully I got it right this time. 211,876. All right, very good. Now, on the calculator, you can just do it with the combination key. You put in the total number you're working with, 49, and then you go to the math key, and then you go to the right arrow key 3 times, highlight probability, and then go down to choose which is NCR, hit enter, and then you got the NCR there. So you know you're doing combinations, and the number you're selecting is 4. And then simply hit enter, and you get your correct answer, 211,876. So again, you don't have to use the formula. You can just use your combination key on your calculator. All right, very good. Let's look at problem number 9. In how many ways can a committee of 3 men and 3 women be formed from a group of 11 men and 7 women? Okay, now, what you're doing in this one is you're going to, for each of the, you got to keep the men separated and the women separated. So 3 men from a group of 11 men, okay, 3 men from a group of 11, and order doesn't matter, right? You're just selecting, so that would be, order doesn't matter, a combination, so 11C3. Then we want 3 women from a group of 7. So in this case, that would be, again, order doesn't matter, so it would be a combination of 7 items total and selecting 3. Now we're going to first select the men, then select the woman. So by the fundamental principle of counting, to get groups of 3 men and 3 women, we're going to find a number of ways to get the men, find a number of ways to get the woman, and then multiply these 2 values together to get our final answer. Okay? So again, when you got 2 different groups, do the combination for each group, and then go ahead and multiply them together. Okay? So we can do the combinations on using the calculator. So what we have here is committee of 3, we want 3 men from 11. So for the men, we're going to do 11 math probability, and then you can just hit 3 to select combinations, and then another 3, we're selecting 3. So the number of ways to get the min is 165. Then for the woman, we got what? 7 women, and we're also selecting 3 women. So 7 NCR 3, and we get 35. So now we multiply the two numbers together, so we got 165, number of ways to get the min, times 35, number of ways to get the woman. And so altogether we would have 5,775 different ways of getting groups of 3 men and 3 women from a total of 11 men and 7 women. All right, so do each one separately with a combination, and then go ahead and multiply the two to get your final answer. All right, let's go ahead and look at problem number 10. The Senate in a certain state is comprised of 51 Republicans, 46 Democrats, and 3 independents. How many committees can be formed if each committee must have 3 Republicans and 2 Democrats? So again, we got to keep them separated. So we want 3 Republicans, right? So again, order doesn't matter. They're just serving on the same committee. So it's a combination. Order doesn't matter. And notice we got 51 total Republicans, and we're going to select 3. Then we got to get 2 Democrats from a total of 46, right? Again, order doesn't matter. So it'd be 46 total, and we're going to select 2. Now again, this committee does not have any independents, so you don't have to do anything with the independents. You would just do the number of ways to get the Republicans, which is 51C3, select 3 from total 51. Number of ways to get the Democrats, 46C2, because we're selecting 2 Democrats from a total of 46. Get both of those numbers together, and then the groups of 3 Republicans and 2 Democrats, you would multiply those 2 numbers together once you solve each one. Okay? So what we have here is, so we'll do each one separately and then multiply them together. So we've got 51C3 for the number of ways to get the Republicans. So 51 math probability over the probability number 3, and we're going to select 3 Republicans. So that number is 20,825. 46 Democrats, total 46 Democrats selecting 2, so 46 math probability. It's a combination, order doesn't matter, selecting 2, that's 1,000. So 1,035 times 20,825, and we get a total of, 21,553,875 committees. Okay? All right, very good. Let's look at homework exercise number 11. In a race in which 11 automobiles are entered, there are no ties, and how many ways can the first 3 finishers come in? Okay, now we're assuming that, again, the order matters because there's a difference between first place and second place, and there's a difference between second and third. So order matters in this one. So it would be a combination, okay? Order matters is it would be a permutation, sorry. Order matters because the top 3 finishers, first, second, and third are distinguishable. They're different places. So order matters, so it's a permutation, okay? And again, permutation so it's a P, there's a total of 11, and top 3, so we're selecting 3, so 11P3. Now again, the formula for permutation is the number on the left, 11 factorial, divided by 11 minus 3 factorial, which would be 11 factorial over 8 factorial, which would be 11 times 9 times 10 times 9 times 8 factorial. Then 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. Those cancel. So our answer would just be 11 times 10 times 9. Okay, that's what we would have left after we reduce or cancel. So 11 times 10 times 9, and we get 990. Okay, and again, now on the calculator, the permutation formula is built in. So you could simply do, you put in the total number, 11, and then you go to the math key, and then you go to over to probability, and NPR is number 2. Order matters, it's a permutation, so number 2. So highlight number 2 or hit number 2, and then NPR, and then we're selecting top 3, so we're going to select 3 out of 11, and there's our correct answer, 990, okay? So the formula is built into the calculator, so you can have the calculator do it for you. You don't have to work out the formula with pencil and paper. You can do it on the calculator. All right, a health inspector must visit 3 of 9 restaurants on Monday. In how many ways can she pick the 3 restaurants? Now, here in this problem, you're just picking 3 restaurants. You're not saying how many different orders. So when you're picking 3 restaurants, okay, whatever, restaurant A, B, C, or you can pick restaurants CBA, there's the same 3 restaurants, even, and so the order doesn't matter, okay, because right here it's just what 3 are you selecting. So then order doesn't matter, so this one would be a combination. Order does not matter, so again, combination. We got a total of 9, and we're selecting 3, so the answer is 9C3. So again, we can do that on the calculator and get our answer, put in the 9, the number, total number, math, over to PRB. Combination is number 3, and we're selecting 3 restaurants, and so the answer is 84 different ways. All right, very good. We're going to stop this session at number 12. This is your math teacher, Dr. Swears. I hope you found this video helpful. If you still need more help on any of these problems, send me an email through the inbox in the Canvas course. Thank you very much.